Gamma-Butyrolastone, also known as GBL, is colorless, water-miscible liquid with pleasant odor. GBL is very common solvent for polymers and alcohols, a chemical intermediate, raw material for pharmaceuticals, and it is mostly being used as solvent in paint stripper, superglue remover, and a stain remover. GBL is manufactured by coupling of dehydrogenation of 1,4-butanediol and hydrogenation of maleic anhydride. The first endothermic reaction on the left shows the dehydrogenation of BDO, which produces GBL. On the right, the hydrogenation of MA to produce GBL also is an exothermic reaction. Due to various disadvantages in these two standalone reactions, both reactions are coupled to achieve higher GBL yield due to higher selectivity to the desired product. This coupled reaction also achieves an effective use of hydrogen between those two reactants, where the dehydrogenation of BDO promotes the hydrogenation of MA. Effective heat transfer among both reactions, because the exothermic reaction will supply required heat to the endothermic reaction, therefore no need external heating or cooling. Lower reaction temperature, which are 30 to 50 degrees Celsius less compared to standalone reactions, and also to avoid formation of hot spots and cold spots in reactor due to moderate heat released compared to standalone reaction processes. Production of GBL starts by feeding MA and BDO to the adiabatic mixer at 25 degrees Celsius and 1.5 bar pressure, along with the hydrogen at 20 degrees Celsius and 1.2 bar pressure. The feed is then transferred to the heater, which heats it up to reaction temperature of 210 degrees Celsius at 1.5 bar pressure. It is then further sent to the reactor. After the reaction has taken place, the feed is cooled to 20 degrees Celsius by cooler and sent to the vapor-liquid separator, where hydrogen is removed as gas and recycled back into the feed. Thus, we are left with a mixture of GBL and water, which is separated by fractional distillation by exploiting the high boiling point temperature difference to yield a purity of GBL of above 99%. The main reactor in this integrated production is a multi-tubular fixed-bed reactor. It is adiabatic reactor, which is designed for higher total conversion of reactants, which is above 99.5%. The reactor is 5 meter in diameter and 3 meter in length and uses copper-based catalyst as the bed. The MA, BDO and hydrogen are mixed and brought to reactor to be catalyzed by copper to produce GBL and water. From the sensitivity analysis, when the feed temperature increase by fixing hydrogen to feed ratio, the reactants conversion and temperature difference in reactor increase. When the hydrogen to feed ratio increase by keeping the feed temperature constant, the reaction proceeds smoothly, which leads to higher conversion rate, and the temperature difference in reactor becomes smaller, which is more desirable.